Hello, and thank you for joining us this morning for our live webinar. We're so glad to be here with you. This webinar is entitled Making Sense of IoT Sensor Data with Golioth and the Infineon Modus Toolbox. My name is Mike Stish. I am a developer relations engineer at Golioth. I've had about 15 years of experience in embedded systems, and you may have seen me previously over at a tech news website called Hackaday, which I was at for about 13 years.
Yep. Hey, good day, guys. This is Clark Jarvis. I'm a technical marketer from Infineon, specifically responsible for Modus Toolbox, which we'll be talking a little bit about today. But I've been doing this for nearly 2 decades, really focused on trying to make sure that people have good development experiences in developing embedded devices.
So I think that there's a lot of good, useful value here between Infineon Modus Toolbox and Golioth. But I think the first thing we should talk about is the problem that we're having, which is we have IoT sensors, so electronics that are gathering some kind of data that are out in the world, and we need to get that back and be able to do something with it. It shouldn't be a hard problem. These are kind of like a simple application, but things start to stack up. So the first thing is you're going to need a way to drive that sensor. And if the sensor changes, you need a way to drive that. You're going to want to make sure that your connections are secure, sending that sensor data back and forth. You're going to want to find a way to store that data and categorize it so you know when it came from the sensor, which sensor came from, where that sensor is. And then you're going to want to have also a secure way to access those. Again, these are not necessarily so hard to solve, but then we started to getting into other issues, like once you have those devices out in the field, what happens if you're having problems with one of them? How do you troubleshoot that? What happens if you realize your client wants a new feature, or you're having a problem with the way that the sensor is being read, and you need to actually push an update to that driver or some other issue? And then also, in our age of chip shortages, as you go to add more sensors, what if you can't get the exact same hardware again? How are you going to manage that? And like I said, I think that the solutions to this through Golioth and Modus Toolbox are really approachable to you. So with Golioth, you can kind of take care of that. I have this device somewhere and I have this cloud here, and we glue those things together. We're secure by default. We have over-the-air updates from day one. We handle time series and stateful data, which you'll see today on the example, and offer a bunch of other things that address the problems I just talked about, like remote logging and managing fleets, and getting some extensible tools to work with devices when they're not like on the desk right in front of you. And through this, the tool that you're going to want to start with first is Infineon's Modus Toolbox. It supports a huge range of Infineon microcontrollers and drivers for those sensors, and it has Golioth built into it. And I'm really thankful today to have Clark Jarvis from Infineon with us. And Clark, do you want to tell us a little bit about what Modus Toolbox is and how people can get into it?
Yeah, no, thanks. Absolutely, Mike. So as yes, we talked about, right? Mike was explaining this kind of scenario where I'm starting with these sensors and starting with connectivity, and then going on to kind of the whole remote management stuff. So as we talk about kind of building applications around that, we're doing an overview of Modus Toolbox as kind of a development environment for that. So kind of what is Modus Toolbox? It is the development environment for Infineon microcontrollers. And it's really provided as a collection of development tools, of libraries, of embedded runtime assets. So the word toolbox is very intentional here, where we see it as really this collection of applications, of tools that you're going to use. And I tend to categorize these into two main areas. So we have the development tools themselves, and then the embedded runtime assets. So whenever you go to Infineon.com and you go to this Modus Toolbox webpage, you say, I want to download Modus Toolbox. What is that, right? So you download this installer, and that is going to install applications on your computers. And these are the development tools. And it's going to include several different applications. You'll have applications that will help you with being able to create a new application. You'll have tools that will help you with managing the software components. So bringing in different libraries, bringing in the Golioth SDK into your application, configuring how you want to use the device itself. So setting up the peripherals. I need to interface with this sensor over an I2C channel or a SPI channel. And in those type of initializations of the hardware itself, there are tools there to help ease that, right, to help generate code for you, to initialize the devices, the peripherals, and on through the middleware itself. Then there's the other side of this is all the runtime assets. And so this would include things like the Golioth SDK, where we have a collection of GitHub repositories with drivers, code examples, board support packages, so you can run on Infineon development kits as well as targeting it to your own hardware. And you combine these all into being able to have a full development environment. When we look at kind of what comes supported out of the box with Modus Toolbox, there's a variety of IDEs that you can use. So when you install that tools installation, you actually get an Eclipse IDE bundled with it. So you can use the Eclipse directly out of the box. It uses the ARM GCC compiler. But if you prefer not to use IDE or have other preferences, we have full support for Microsoft Visual Studio Code. You can use third-party IDEs like IIR's Embedded Workbench, or the ARM Microcontroller Developer Kit with the Kyle Microvision IDE. And those are all supported out of the box. And I'll touch a little bit more on that in an upcoming slide. But at the heart of what Modus Toolbox is, at the heart of Modus Toolbox is a make-based build system. And so this gives you complete access to a command line interface. You can do everything from being able to create a very scriptable build environment with kind of pre-build commands, post-build commands, integrated into continuous integration systems, be able to tie it into your own source code management system, whether you're using GitHub itself or GitLabs or an SVN, right? All these things tying together at a very low level to give you complete control, complete flexibility to really allow you to create a development environment that works best for you. In kind of the ease of use side of it, so in addition to working with an IDE, there are these other configurators, tuners, and utilities that I kind of alluded to. A couple of the key ones that I'll talk about more are things like a project creator, a UI to help you create projects, actually reaches out to GitHub and pulls down those projects. A library manager, which we'll see in part of the demonstration for this, of being able to reach out and say, okay, I've got my project up and running, but now I need to extend it by bringing in the Golioth SDK inside of it, or I need to bring in this other library or piece that I want to supplement my application. The device configurator, which is where we're going to do kind of our initialization setup, handling all the clock configurations, handling all of the pin muxing, and how we're going to use different peripherals. And the list goes on. Things to help you import BSPs, handle security, going into some of the HMI with CapSense, which is one of the unique IPs available on PSOC devices, to be able to configure and do tuning, real-time tuning, to see how the capacitive touch, how your electrode's behaving. So I wanted to touch on two of these utilities in particular that really are some very beneficial ones, and ones where we have kind of a specific tie-in. So we are doing this presentation with kind of a Golioth perspective. Is how would I get started with that? So the first one I want to talk about is the new project creator. Reaches out, right? So we have all these repositories in GitHub that are all kind of maintained by these manifest files and data files behind the scenes, but simply launch the tool, specify the board that you're wanting to work with, and then it queries the GitHub repositories that come from Infineon, that come from Infineon partners, and says, okay, here's everything you can do on that board. In this screenshot, you see a use case of pulling up the Golioth code example. And with that, I can then generate the project that targets the IDE that I want to choose, whether I want to do it directly in the Eclipse IDE that's bundled with Modus Toolbox, VS Code, IIR, Kyle, you get to choose those. And it'll have specific steps. Certainly for the Eclipse IDE and VS Code, really simple. They just open up directly inside of those IDEs. For ones like the IIR and Kyle, there were steps to be able to use their specific project connector files to import those into those IDEs. Now, once you're in the IDE and you're working with it, you may need to add some additional behaviors or modify that. So that's another key utility I wanted to talk about, was the library manager. So it serves kind of two primary functions. One is to manage the actual board support package, the BSP. So this can be useful if I'm starting with an Infineon development kit and I've got code examples, reference projects, maybe a proof of concept running on that. And it's great, it's working, but I need to now go target maybe a different board that's got additional capabilities or features that I need to as the project evolves. Or I'm targeting my actual hardware, right? Because we're going to go to the market on real hardware. So I'm able to manage that BSP and actually kind of plug and play those pull out the BSP for the development kit and plug in a BSP for my hardware and be able to port that application over quite easily. The other aspect is much more in line with the name, the library manager. So I have these GitHub repositories, again, coming from Infineon partners, and be able to pull in, oh, I need this Golioth SDK. So I'll be able to pull that into my project, a couple of tweaks to either the make file or the include files that are all driven by the documentation provided by that middleware, and have that integrated into my project. So it makes it very easy to be able to add in these pieces to the application itself. Now, so a couple of resources, and I only got 2 more slides. So a couple of resources that you guys can use if you're interested in getting started with Modus Toolbox. The first one is some software training. So these are software training modules. The QR code and the various links here will take you to a GitHub page. This is the Infineon GitHub page for Modus Toolbox. And we have guided kind of self-paced training. It'll take you through getting started, working with different devices, and then going into some of the specific software lessons, software examples that you can go through to learn Bluetooth, Wi-Fi, machine learning. And then the last one is, again, more links that we have. We have some technical videos that you can watch. These will range from just kind of getting started, kind of what is Modus Toolbox, a lot of the same content that we just talked about today. It's more getting started. How do I get it installed? How do I access the documentation? And then finally going into some how-to videos. So kind of these guided video tutorials of saying, hey, let's just at least get a blinky LED up and running, or showing how a PWM. We always say that, if you get the blinky LED up and running, that's it. That's all you got to do. Everything else is a piece of cake. So regarding the rest of it, right, the piece of cake stuff of it, then I'll turn it back over to Mike to now go through the actual Golioth SDK and integration with Modus Toolbox.
Yeah, if you can blink an LED, you can move the world, Clark.
That's right. That's all you got to do.
So that's a great overview of Modus Toolbox, which is what we used for the hardware demo that we're going to jump into. I will just do full disclosure. I pre-recorded this demo. I pre-recorded it live, but part of it's because I wanted to skip through some stuff that was going to take some time at the end. So let's jump in and look at the hardware actually sending sensor data to the internet. The device that I'm working with today is the PSOC 6 Wi-Fi and Bluetooth prototyping kit. Here it's running an edited version of the Golioth example from Modus Toolbox. I've added to it the CapSense example so that both work together. That CapSense example enables this slider that will dim the LED. It also enables the buttons to turn off and on that LED. And by putting the two of them together, I've taken the data from the CapSense and I'm sending it up to the cloud. So if we look at Golioth right now, this is our web console. This is a digital representation of that device. And so we can look here, get a status update to see that it's been online for 14 minutes. A few seconds ago, it reported in. We can see what firmware it's running. There's some other data available here, and along these tabs we kind of unlock the power of Golioth as we see this is a time series database, so we see in real time that data coming in. It has timestamps along with it. If we unfold it, we can see the sliders currently at max, which is 300. If I slide it down about halfway, we should see those results change. With the on and off buttons, I'm using a stateful database, which is called LightDB State, that tells you the last reported status of it. And so on this button state, if I press the off button, we should see this come to false pretty quickly. And if I press the on button, we should see it come to true, pretty low latency on those, which is nice. The other thing I really like having is the ability to look at logging messages remotely. And so these are coming in from the device right now. I can look at them coming in live, or I can use the time windows to change where I'm looking at. And you can see there's a log level, so anything from debug to error. The module is like the C file that sent it, and then the message coming in, this one is basically a hello world message, but you can see the power of reporting back to what's going on with the device and being able to troubleshoot it that way. You may not want all of your info messages to be coming through the internet all the time, and we will often use a remote procedure call for that. So you could do a set log level remote procedure call, and you'd put in 1 for only error or above. The other thing is we can see that these are coming in at a 2-second cadence right now. We call this the loop, and it's what we usually use for reading sensors, sending, in this case, sending hello messages. But that is a setting service that is fleet wide. So you can change on your entire fleet this setting, or you can change it for groups of devices. Here I'll be changing it just for this device. And if I change it to 4 seconds and go back to logs, we're actually gonna have to look at historic logs because we should have already had the log come through. Let's see here. Yeah, there it is. All right, so here's the log that came through that says, hey, I just got a message that I need to change my cadence to 4 seconds. And then as we see the data come in, you can see here's 46, 42, 38. So these are coming in now on like 4-second cadence. So it's great to have all of the control and all of your data coming in on Goliath, but you probably want to do something with that. And we have a REST API for that. So I've taken an API key from this project right here, and I've given it to Grafana. And so Grafana is a visualization platform that you may already be familiar with, but this very easily could be any other platform or like a smartphone app, anything that you want to connect to a REST API with. And if I turn on the small camera here, we should be able to see as oh, my camera's not coming on. Give me just a sec. There it is. As I change this slider, we will see the graph update. Now, there's about a 5-second refresh on Grafana, so there's some latency there. But basically what's happening is as I touch like the off button on this device, the device is reporting it through Wi-Fi up to Goliath, and then Goliath's REST API is being pulled by Grafana in order to change that. There is also a WebSockets connection if you want to use WebSockets in order to get live real-time updates. We kind of go back and forth between whether to use REST API or WebSockets based on the application. This is a wonderful place to start at, and you know, seeing this demo with the slider is what the end goal of this webinar is. But let's look at what it takes to get there. And I think the first thing that we want to do is start with a known working example, and we can use Modus Toolbox to do that for us. So in this console view, I am in the Modus Toolbox tools directory, and we can look at the tools that are available. We're going to be focusing on 2 of them today. The first one is the project creator, and I can just load that up. It's going to launch a GUI, and the first thing the GUI asks for is what board we're using. So this is a prototyping board. I know it's the PSOC 6, and if you look at what's printed on your board, you'll find this number right here. And the next thing it's going to ask for is a target IDE. So I want to be using Visual Studio Code today. So I'm going to select that, and then this will create a workspace for me. And then Goliath is an example in Wi-Fi. If I filter for it, we should see it pretty easily come down. So the Goliath Goliath example code is what I'm selecting. And then I can choose a name here for my application, and this is going to be used for the folder as well that it's stored in. I'm locating my projects in this directory right now. You can see this says Goliath example 1 because I've already pulled down Goliath example, and I don't want to take up time right now to clone all those repositories. So I'm going to skip the create button, but you should click that and it'll put this project example together for you. And when it does, you can go into VS Code and click Open Workspace from File. And when we look at the folder that I installed it in, my projects folder, here's our Goliath example and Goliath example code workspace. So I can open that up. VS Code's going to do a bunch of its helpful configuration stuff as you first start. Let's pull this down. Yeah, all right, and let's see here. Let's first look at how this project is put together. I've been in here before with that file, so that's why things kind of open up by themselves. But we can see that Goliath example is the project itself. There are 2 different firmware builds in here. So one of them is a bootloader. The other one is the app itself. And the reason there's a bootloader is because we have the ability to do over-the-air updates. So if you remember when we looked at this device, we see that it's running the main package at version 2.0. that is the firmware that's being reported. And in order to do firmware updates, we actually need to use the command line to do the build and the flash. There are some tools in here for Modus Toolbox for programming, and we are not able to use that for this that has the two different firmware packages. The IDE is just not set up for that. But don't worry, the code for compiling them and flashing them is pretty simple. The other thing that I should mention is if we look inside of this Golioth example folder, the README has everything that I'm walking through right now. So how to set this up, how to give it credentials, and build it and flash it in the 2 steps. All of that is right here, and you'll be able to find it again. So the first thing that I want to do is I want to build the bootloader and put it on the device. And so I'm just going to open up a new terminal, and it'll give you this selection here for the bootloader. Let's open that up here. Now the command that you're going to normally use is make build proj. I've already done this. I don't think we need to watch my compiler at work, so I'm going to do the next step, which is make program proj. And that will be pretty quick because it's a small binary, so it just has to erase a little bit of flash and write it again. All right, there we go. All right, so that one's all done, and we can get out of that terminal now. There's a little bit of setup for the second step. The Golioth app requires some credentials. And so in Golioth app under source, there's a Golioth main.h. And we can see in here, I've already set up my Wi-Fi SSID and password so that the device can connect to your Wi-Fi access point and have internet access. And then pre-shared key ID here. Now, this is because Golioth is secure by default. So if we go back and look at the Golioth console and the representation of this device, there's a credentials tab, and it has a pre-shared key ID and a pre-shared key in it. So I just copied these out. You can add more of these if you want. When you create a device, it automatically tells you to generate a pre-shared key, and that's because, like I said, Golioth is secure by default. You do have the option of using certificate authentication with Golioth, but it's a little bit easier to show PSK, so that's what we're using today. So I've copied those in and saved this file, and that completes the setup for the app part of this. And so we just need to do the same build and program step. So I go to new terminal and I select the app part, Golioth app. And like I said, I would normally do make, not a mic, make build project, but I'm not going to make you watch the compiler at work. So I'm just going to do a program and try to turn on our webcam again. And so it's being programmed right now. You remember before the light was just on solid and you could dim it with the slider. That was the edited version. What we should see now with this is once it gets done programming, the light should be blinking. That'll show you an indication of that you're successfully running. And we will also be able to open up a console. So let's open Minicom is the one that I like to use somewhere. Let's see. There we go. All right, so we have our light that's blinking right now. Right now the device is working on reestablishing the secure connection with Golioth, so it may go on a few, there it goes. All right, so it got a connection with the Wi-Fi, connected to Golioth, and it did a bunch of checking in. So notice now the current firmware is version 1.0, and if we go back to our device representation and see, we refresh the status here, you can see that now we're running main package 1.0, which is super cool. The other thing that I've done in preparation for this is I took the binaries that were built and I uploaded them as artifacts. So the thing that I just programmed is version 1. The thing that I was showing before that had the dimming built in is version 2. And I've rolled those out I've created those as releases. They're not currently rolled out. So let's roll out version 1.0 and see what happens with the device. And when we do that, the device will tell us that it received a manifest, but it does not contain a different firmware version, which is expected because we were running version 1. But now let's tell the device, hey, I have a new version for you. So I have version 2 staged here. And if I toggle that and roll it out, we should see the device receives the manifest. It says I'm current version 1.0. It's going a little faster, 1.0, and I'm targeting version 2. And then it gets ready and it starts downloading these blocks. So it's going to download all of the blocks on this device right here. And I'm not going to make you wait for all of that, or we'll actually see how all that goes. I want to walk through a few different parts of the over-the-air update process. So one of them is the ability to see what state your device is currently in. So if we go to this firmware tab, it tells us that it has version 1.0 running on it. It's been told to get version 2.0 as a target, and it's currently downloading that. And it gives you a timestamp as well, which is pretty cool. So as it goes through that process, this will change. Once it's fully downloaded, it's going to reboot and look, and you'll get an updating message here. Before, the message would have been idle. I didn't show that before, but that's just the steady state is it'll tell you the version, it'll have no target, and it'll say idle. So we can look at that. All right, so we finished our block download. It's telling us that it's going to reboot in 5 more seconds. And once the device reboots, it's going to spend some time here verifying the image, because the images are signed, and then it has to move the image from the secondary slot where it was downloaded into the primary slot before it can start running on that. So I might skip forward here and wait for that process to continue. All right, previously I had paused the recording and I missed it. I did not unpause in time for it to get done writing the flash, so I'm going through the process again a little bit later on. But let's just show you while it is rebooting, we can look at the Golioth web console again, and we can see that it tells us it's in an updating status. We're waiting for the primary slot to be done being erased, and for the secondary slot to get moved in. This takes, about a minute and a half, something like that. All right, so we just jumped past that waiting period, and the device has rebooted with the new firmware. It started, picked up on Wi-Fi here, got a connection to Golioth, and reported in that it is running version 2.0 of the firmware, and that is what is currently rolled out from the web, so it has no update to do. And if we go and look at a reported state, we are now in 2.0 and we are at idle. So this is a great overview of the over-the-air firmware update process. I think what we probably want to do next is jump into this code and look at how these API calls are working and how to connect up the sensor data. So I'm going to end the pre-recorded demo now, and we'll go through that code live.
Hey, Mike, you are muted, as a disembodied voice says.
I was muted the whole time. All right, so thank you so much for bearing with us there. I know it was a ton of stuff, and it's all examples that are in the Golioth example code that you can get pulled in through Modus Toolbox. But I think a valuable thing to finish off the webinar would be to show you how to, and the technical term is smooshing together code examples. So what I did for this example is I took a capacitive sense example from Modus Toolbox and I added it to the Golioth example. Now, you don't have to add it to the Golioth example, but like I said at the beginning, I think if you're going to put an IoT device in the field, you have to have over-the-air updates. Otherwise, it's not really like a production device. And so the nice thing about the Golioth example in Modus Toolbox is it already has that over-the-air updates part set up for you where you have to have MCU boot and 2 sections and stuff. So we recommend starting there because that is kind of non-trivial to set up, and that's already set up for you. But adding sensors is actually pretty easy in Modus Toolbox. And so let's kind of go through that process. There is a capacitive or cap sense example. And I pull it in the same way I did at the beginning of the Golioth example using the new project manager. You put in the board name, you put in VS Code or whichever ID you want to use, and then you can type in CapSense, and it'll give you several to choose from. And the great thing is Infineon has a CapSense buttons and slider free RTOS example. And that's nice because the Golioth example already uses free RTOS, which means you're going to have a scheduler, you're going to have threads, and we can kind of just Infineon's done such a nice job of modularizing this sample. We can use the same library, the same files from this example in Golioth. And so the actual part of the code that's in the main.c of that capsense sample that kind of matters is just this section. So this section is a couple of queues that are used by the capsense example, and then a couple of tasks that start up the capsense thing. And so we're going to pull that into Goliath as well. So let's jump over to a library manager demo. I have VS Code up. All right, let me just make sure. Yep, you can see that. All right, so right now, I am going to take and add, let's just say, add a folder to the workspace. And this folder is from my projects directory. You can see here is the capsense buttons and sliders for RTOS example. I'm just going to pull that folder in, and we see all of the files that come with that. And I'm just going to grab the important files. So there's a C file and a header file. And if I copy those and go up to my Goliath app into my source folder, I should be able to paste them right into my source folder. So here they are right in my source folder. The problem is that's really just the application side code. It doesn't have all the support libraries. I'm done with this one, so I'm going to pull this one out. Let's see, remove from workspace. All right. I don't have all the support files that I need to run these. And Modus Toolbox will take care of this for you, which is super fantastic. So if I go to my terminal, let's see right here, and I'll make this big. You can see I am in the tools directory here, so we can see all the different Modus Toolbox tools. The one that I'm going to open is the library manager. Oop, that's not it. Library manager. And again, a GUI will come up for this, which is very easy to use. And we don't need to put in the board because we already know what board we're using from the project itself. We're adding support libraries. So you can see here is my BSP, my board support package that Modus Toolbox previously set up. And then I want to pull in my capsense. Actually, I want to click add library down here. And here's where I want to search for capsense. And it comes up. Even though there are several samples that you can do with the new project library, there's only one library for capsense, which is pretty simple. And then if there's any other dependencies, Modus Toolbox is going to take care of that for you. So I add it, and then I click update, and this may have been a bad idea as I kill my network connection to the webinar, but it really should just take, like, what was that, 15 seconds. And that's in. And now things will actually build. I haven't actually done anything yet, but if I needed to build the project, I could. So the point at this point, we want to actually connect things up. And so I'm going to just jump over, just take another glance at what files are in here. These are the 4 that we added, the capsense and the LED task. I'm going to jump over to the demo that I was running at the beginning because it has all of the code work already done in it, and we can just look at what that code work was like. All right, so we've opened that project up, and you can see here are those files that we had previously copied, and I have made very minimal changes to these files. So I think the capsense file is the only one that I've actually made changes to. I added some global variables, which is not necessarily the best way to do this, but it's an easy way to get the point across. So there are other RTOS-y ways that you can do these things, but this is simple. So I just took where this library is detecting button touches, so the on and off button, and then the slider as well. And for each one of these, when it detected it, I set a global variable that can then pass that data off. And I made that global variable available in my Goliath main.c file. Let me pause for just a moment on these global variables. The one other thing to get this running, and I showed this in a previous slide, is I pulled in these tasks and these queues. So I pulled in the files from the other example. They're running on what threads, they're called tasks in RTOS, and I've just made sure to set those threads up so that they're running. At that point, I went into where those threads are running and added the global variables. And then I just mapped those over to my Goliath.main file. Everything that's different is happening down here. So I just set up a couple of local variables, and these are used to tell if I've already reported new data to Goliath or not. So in my while loop in this Goliath thread here, I'm just checking to see if the last reported, the local variable, matches the global variable. And if they do If they do, nothing happens. If they don't, then we know we have new global variable data, and we go ahead and format that and send it up to Goliath. I like to do printf just so you can see locally what's going on. But as far as sending the data up to Goliath, it's a single API command. The APIs are really easy to use. There's a ton of helpers. I actually have a slide for this, so we'll get to that in a second. But here I'm sending up either a true or false for the LED being on or off. And then I also check the slider value that's reported by the CapSense library is a 0 through 300 value. So I'm really just checking, do we have a new value there? And in this case, even if it doesn't change, I'm going to send that value every time we go through this loop, because since this is like a user input, we want to know at any given point in time where that user input is set. The same thing, like if you were measuring temperature data, you wouldn't probably want to just measure when the temperature changes. You'd probably want to measure the temperature at every point in time so that you have like a historical record of what that sensor was reading. And the Goliath API takes care of everything kind of behind the scenes from there. So I can switch back to slides here. These are the global variables that we were talking about before. I think I just put these in for safety, really. And then everything happening in the Goliath loop here. I do want to take just a moment to talk about the Goliath APIs that are being called. So I have Goliath API. All right. So this is the Doxygen for the Goliath library that is in, or the Goliath module that's in Modus Toolbox. It is a component of FreeRTOS. So if you're using FreeRTOS, Goliath has a support for that. And you're probably using FreeRTOS if you're with Modus Toolbox, just because you need to have the network connection. And it makes it pretty easy if everything's already set up for that part of it. You can see here, these are the stateful database APIs. There's a ton of them. Don't be intimidated by this, but it's really just convenience functions. So for instance, if you're only sending one integer, like 0 to 300 for the slider, it's a lot easier to call an integer than it is to, like, say, make a JSON package and send that up. Or we also support CBOR serialization, so you could make a CBOR package. But if you need to work with one specific type of data, there's helper functions for that. If you need more generalized packages of data, there are also API calls for that. The Goliath example that we were walking through that's in Modus Toolbox, the Goliath main file has a ton of demonstrations of how to use these. So I just pulled a couple out of here. Sending stateful data is the LED on or off. Sending time series data, like what is the temperature as we go through, what is the slider setting. We also have an API that makes really complex things a little bit simpler. So this is all the code that you need in your application in order to set up an over-the-air update with Goliath. So basically, the bulk of it is just telling Goliath what version of firmware the chip is currently running. And this uses snprintf to format that in a way. And then the actual API call is this Goliath firmware update in it, where you just send it the client, which is what connected to the Goliath service. Client is called in all of our API calls, just so you know which connection is being used, and then the actual version itself. But a lot of other things, like the ability to set device settings. So let's say you have 10,000 devices in the field and they're all reporting sensor data every 30 minutes. What if you wanted to change all of them to every 60 minutes or every 6 minutes or whatever it might be? The settings service allows you to do that fleet-wide or with groups of devices or individual devices. But on a firmware side of it, it's pretty easy to set up. So there's one call that registers a callback and says, this key, the loop delay S key, is what setting I'm looking for. So then the Goliath servers know whenever that changes, it will notify this device. And then there's just a callback that you set up. In this case, the callback is going to print out a logging message, and then it's going to actually change that delay value that's stored locally. So those settings are things that if you didn't think about them when you started your IoT fleet, you're probably going to need them down the road, and they're already available through Goliath. We also, have talked mostly about the device side, because this is kind of a device hardware heavy webinar, but that's only one part of the puzzle when it comes to IoT. You also need to be able to do something on the cloud side and grab that data. So everything from making sure that the connection to the device and the connection to the data are secured is taken care of by Goliath. Everything that you can do on our web console that I was demonstrating is available through our REST API. And we also have command line tools for these. So when you're looking at doing automation tasks with your company, those are available to you. I would invite you to give it a try. There's a dev tier on Goliath. So if your first 50 devices are free, I don't think I've ever had 50 devices running all at one time on my development desk here. So really, as you're, proofing out what your cloud management solution is going to be, where you're trying to figure out how are my IoT devices going to work, you should be able to do this without, incurring payment for the service. And Goliath thinks that's important, has made that available there. That is the wrong slide. I want to thank you today for coming, and Clark, thank you so much for being here, helping with this. I've seen some questions come up in the tab, which we'll get to in just a minute. I'm sure Clark's going to answer the majority of those. On the right here, I've put the QR codes that Clark mentioned before for the technical videos and the software training around Modus Toolbox. One of the things that when we started working on this, I didn't realize that there was a VS Code option. I was using Eclipse, and I much prefer to use VS Code. Both are supported by Modus Toolbox, and I just need to do a better job of reaching out, talking to the Infineon folks, looking at the documentation as well. All right, let's jump into some questions. One of them that I saw was about adding custom device definitions, Clark. So as you move away from like a prototyping board like the one that I was using, but you have an Infineon chip on it, what does it look like to add device definitions?
Yeah, absolutely. So we do take a concept of a BSP, and I know there was a reference to Zephyr in there, and maybe you guys could even comment on that as being much more Zephyr experts than I am. But concepts are very similar, right? A BSP, as it's defined in Modus Toolbox, is really kind of this self-contained entity that's going to have everything from like the linker scripts and startup code that are needed to bring up the device itself, right? What package am I using for the device? What's the actual device? And that BSP will contain everything that's needed to be able to do the device initialization. So everything about the clocks. You can define what you want the peripheral configuration to be. So we mentioned a device configurator tool. That tool is responsible for defining how I'm using clocks, how I'm doing my pin muxing, and everything that gets generated out of that tool or kind of saved as the process of making those selections in the tool goes into that BSP. So a BSP not only defines the device itself, but how the device is initialized and used. Are there any specific drivers that are needed for that particular BSP? And that ultimately what that's really going to come down to is the low-level drivers that are needed. So the different APIs that I have to be able to turn on CapSense or to be able to turn on a SPI interface to a particular sensor. And all that gets encapsulated into a BSP. Now, how do I manage and create BSPs? So Infineon provides BSPs for all the development kits, but certainly you don't go to market with a development kit or a prototyping kit. You do it on your own hardware. So tools that are there inside of Modus Toolbox to kind of assist you in making that migration, making that change, primarily centers around the BSP Assistant. So this is actually a fairly new tool. This was all possible before, but it was a little bit more manual, kind of done at a command line or kind of entering different arguments. But BSP Assistant introduces a UI that kind of guides you through that. What's the actual device, the marketing part number, the package type that you're using for your BSP? Make that selection, and then that drives a lot of those other selections to say, okay, well, here's the initialization code, here's the configuration, and allowing you to define the layout, right? Mapping the schematic for your board into how the software, how the device itself gets initialized. So that's the concept of a BSP. And there are also various macros that get defined. We kind of saw some of those in the code that Mike was going through. You can define these macros as part of the BSP as well, so that your application code becomes very portable. So we'll take a really simple example of an LED. There would be a macro for user LED. And as long as I'm using that macro inside of my application code, regardless of the BSP that I'm using, I can switch it out to my hardware as long as that macro user BSP is defined as, so that's port 4 pin 3. that I don't have to touch my application code regardless of swapping out and interchanging the BSPs.
Great, thank you. I see another question here. Someone asked how Goliath is differentiated from AWS or Microsoft Azure. And I think that one of the things that we look at is Goliath is going to take care of everything from what the device is doing to where the cloud is actually being used. Once that data is available, if your web team wants it on Azure, AWS, or Google Cloud platform, those are all available. We have output streams that you can immediately get your data. And so one of the things you can do is stand up a test fleet with Goliath, set that output stream, and make sure that that data is coming in the exact same way that you expect it on AWS to proof it out before you build more into that fleet or move it over. One of the ways that I do think we have a big differentiation is everything is already taken care of for your micro controller level devices. So we make sure that you always have an encrypted channel there. We make sure that the data is being formatted in as efficient a way as possible for being sent to and from the cloud. We make sure that that data is stored in the way that it was received and it's available on the other side. All of these things are available through other platforms, but it's not that kind of like ready-made, I have a microcontroller project, I'm immediately online. The other thing I think is of value is the platform that you're prototyping on with Goliath is going to scale along with your project. So you don't get to some like blocking function at which point you have to like switch over to the actual production area. As you stand up your prototypes, you're going to be able to use that same infrastructure on your entire fleet. Oh, it looks like the same person asked, must be going through our sign-up process, so asked about 3 different options. So there is a wizard when you go to console.goliath.io for the sign-up, and it is going to ask you like which of these 3 boards do you want to try out, but that doesn't actually lock you into that hardware. It just gives you a link to our docs for those boards and setting up. So in that case, don't worry about that. Go through the process that's drawn out in that README for the Goliath example in Modus Toolbox. And any docs that you want along the way are at docs.goliath.io, but you don't need to like go to the specialized platform docs that are recommended in that wizard. One more here. All right. How does Goliath process the data from the IoT devices? For example, after Goliath gets the data and shows them nicely. So yeah, that's a good question. There are a few different ways. One is what's happening under the hood with the Goliath SDK. And so we use CoAP and CBOR serialization as 2 methods of making sure that the data you're sending is as efficient as possible, which matters a lot for things where data is important, like if you're doing cellular, but also matters for battery powered devices, which a lot, if not most, IoT devices are going to be battery powered. So that radio on time, we really want to kind of crunch that down. So our system, our SDK is using CBOR serialization to package everything up and then sending it over CoAP. On the cloud side, it's taking that CoAP, unpacking that CoAP packet into the CBOR and then putting that into a database that is either available through our REST API on our web console, or like I said, through output streams to go to your own servers, your AWS, whatever other place you might want it to be, or you can just use it for Goliath if that meets your needs. On the user side and the application side of it, what we often show is packaging things up as JSON for prototyping, because you can make a JSON packet and then send it with one API call to an endpoint, and you'll see it represented as JSON on the cloud. However, that might not be the most efficient. Like if you're sending a ton of data and endpoints, you might not want to do that. So you have the option of using CBOR serialization yourself through a library, which is not hard to do if you haven't worked on it before. It's basically like you make an API call that says, add this key and this data to my packet, and then you send it off that way. All of those are going to be visualized on the cloud as JSON, but since it's not necessarily always fun to work with JSON on C code, once things get more difficult, I do recommend you looking into that CBOR and giving that a try, because I found it very valuable. We may have come to the end of the questions. Do you have any questions or any extra tidbits, Clark?
Yeah, you know what? There probably was one little tidbit as I was watching, going through the integration with VS Code and using this. So one quick kind of a tip is the tools themselves. So certainly they can be launched from going to the tool directory. Just like I think as you were showing, the tool directory has a list of all the tools that are included in Modus Toolbox. They all work in the command line. They can be opened from the command line as well. Oftentimes for several of the key tools, they can be opened directly from the project folder. So if I'm inside of that project folder, I can type make config, and that'll open up the config tool with all of the project settings already brought in and ready for me. Similar with the library manager, make modlibs, right? So sometimes you have to figure out what the correlation is, but it's in the user's guide as well. But a quick tip for being able to work with projects, kind of being able to easily open these various configurators and tuners up from the command line. That can often be done from the project itself, the project folder itself. It makes it a lot easier because you don't have to then go in and open up the project or go browse for the directory as well. So kind of a quick tip there. Outside of that, I mean, should be easy enough to get started with Modus Toolbox and Goliath, right? An easy code example that we showed there. Easy to bring it into another project using Library Manager. So hopefully everyone took away those kind of key benefits from this.
Oh, that's awesome. I'll have to give that one a try. I haven't seen that make command before, but I know there's a ton of other useful make commands. So maybe I'll do some digging after the webinar.
Yeah, absolutely.
Yeah. So thank you so much. It's wonderful to partner with Infineon for webinars like this. And Clark, couldn't have done it without you. Like I said, I kind of pivoted on what I was showing, and it was so much of a better experience because I found the tools that I needed just with a little bit of help. So do go ahead and check out Modus Toolbox on Infineon. Give Goliath free device tier a try, and we hope to see you on the next presentation.
Yep. Thank you, Mike. Thank you all.